Today we are doing intervals of convergence. Intervals of convergence. And I have a little intro for us because this is a really important topic and I need for you to get a good feel for it, a good feeling for what we're doing, why we're doing it. So I'm going to find the Taylor series for ln of x centered at x is equal to 1. Okay, so I take f of x, plug in 1, we get 0. So our first term is 0. The first derivative at 1 is 1. Second derivative at 1 is negative 1. Third derivative at 1 is 2. Fourth derivative at 1 is negative 6. I'm keeping going because I haven't found a pattern yet. Fifth derivative at 1 is 24. The sixth derivative at 1 is negative 120. Now I think I see the pattern. Negative 120 is negative 5 factorial. 24 is positive 4 factorial. Negative 3 factorial, 2 factorial, negative 1 factorial, 0. So they're alternating in sign, and it's all the factorials. So the derivatives are factorials. Okay? So when we're writing our series, here, okay, start with the constant term, derivative over factorial x minus 1 to the power. So that's the first derivative. Second derivative over 2 factorial, x minus 1 squared, etc. The factorials all reduce. They all reduce. And they reduce to this series. Okay? So this is the series centered at 1 for ln of x. Okay? That means that ln of x is equal to this series for some values of x. Not for all values of x, though, because I notice that there's no factorial anymore in the bottom. If there were, like the ones for sine x, e to the x, cosine x, then those converge for all values of x. But because we lost our factorials, I know that it's not for all values of x, only for some values of x. In fact, I know that since we're centered at 1, I know that there's some interval around 1 where we converge. Some interval. Okay? Alrighty. In my calculator, I put in for y1, ln of x, and for y2, I wrote this series, I put in the series up until the 7th degree term. So you can see I went all the way up to the 7th degree term and then I just stopped. Okay? So when I graph this, I'm going to zoom 4. There's ln of x. There's ln of x, and notice that it has an asymptote, okay, on the y-axis. It's taken some time to graph that next one, but there it goes. And I see that 7th degree polynomial right here, and see how it lined up. It looks like it lined up from about here to about here. That is the interval of convergence. Okay? If I hit trace, you would see a slight difference in the values. Slight difference in the values. Why? Because I only went up to the 7th degree. If I went further, you would see it closer and closer and closer to the exact value of ln of x there. Okay, this is the interval of convergence, you guys. From 0 to 2. That's our interval of convergence. So from 0 to 2. Okay? And I could prove that to you after what we learned today. Alrighty? Okay, the center is 1. Center is 1. We're going to use that today. Okie doke. Let me grab my notes packet now. Here is a notes packet. Alrighty. So the drawback to using a Taylor series is that we don't know where it works and where it doesn't work. That's why we find the interval of convergence. These are worth big points on an FRQ. So we need to show all of our work. So let's say that we found a Taylor series for F to be this series. This is the general term. And if you wanted to, you could write that general term in a series like this. So if you put it with sigma, it would be this. The sigma, the sum, is everything here. Okay? All right, but that is the general term just as repeated over there. And then you carefully find what n value you're starting at. Okay, at what value of x is this series centered? This series is centered at 5. I know it's centered at 5 because of all these x minus 5s. I know it's centered at 5. To find what values of x make the series converge, we will find the radius of convergence and the interval of convergence using the ratio test. The ratio test is our friend here, you guys, okay? So, ratio test always begins with limit. Limit n goes to infinity. It makes no sense if you don't write limit, so be sure to write limit. And use an absolute value bar here, okay? It's going to be crucial to use an absolute value bar because we have these x's. We're going to have x's in here. We need the absolute value. It is not necessary to write the -1 because of the absolute value bars. So I'm not going to write the -1. I'm going to have everything else. Ratio test, as we learned in the last unit. Ratio test, we begin by replacing every n with n plus 1. So we'll have x minus 5 to the n plus 1 over n plus 1 times 2 to the n plus 1. And we multiply that by the reciprocal of the nth term left alone. So n, 2 to the n, over x minus 5 to the n. Close your absolute values. All right. The n and the n plus 1 do not reduce. However, when we take the limit as n goes to infinity, that ratio will go to 1. So they don't bother me. I'm not going to touch them. They just are going to disappear when I write my answer to the limit. Okay? The x minus 5s do reduce. They reduce, leaving a single x minus 5 on top. The 2's do reduce. They reduce to a single 2 on the bottom. We did all this in the last unit. So this is going to be the absolute value of x minus 5 over 2. Alrighty? The absolute value of a fraction is the absolute value of the top divided by the absolute value of the bottom. So this is the absolute value of x minus 5 over the absolute value of 2, which is just 2. Okay. So far, I have earned 2 points on the FRQ AP exam. 1 point for setting up this ratio, and 1 point for taking the limit of the ratio and finding the correct limit. So 2 points. Okay. Now, in our last unit, we didn't have x's, and we would just get a number here. What did we do with that number? We compared it to 1. If this number was bigger than 1, we said that the series diverged. If this number was less than 1, we said that the series converged. If this number was equal to 1, the ratio test did not work, and we had to use a different test. We want the radius and interval of convergence. We need to know what values of x make this thing less than 1. So we will set it less than 1. Since we have a fraction less than 1, I'm going to multiply both sides by 2. Multiply both sides by 2. and we get that. Okay? All right. Look what we have here. We have absolute value of x minus 5 is less than 2. 5 is our center. Visually, look at visually what's going on. 5 is the center. I know, since there are no factorials, I know that there's some interval around 5 where we will converge. The rest of the time we will diverge. I know this. Okay? I know I'm going to diverge out here, converge in here. Okay? And the x minus 5 gives me the center. The 2 gives me how far I go beyond 5 to converge. This is our radius of convergence. Okay, so 2 beyond 5 and 2 in front of 5. 3 to 7. Okay, x is between 3 and 7 with 5 right in the middle, and the radius is 2. Okay, all right. I just earned 1 point for setting up my ratio, 1 point for taking the limit of the ratio and getting the correct limit, 1 point for what they call the interior of the interval of convergence. That was worth another point. Okay? All right. I said that, plus 1. I said that these were worth, well, I don't know if I said it. These are worth 5 points, usually worth 5 points, sometimes worth 4, but at least 4 points. Here are 3 of them. Okay? Here are 3 of them. There's still 1 to 2 more points to earn on this problem. Okay, so I know that I diverge here and here. I know that. And I know that I converge in here. What I do not know is what happens right at 3 and right at 7. Do I converge or do I diverge? Right at 3 and right at 7, right at 3 and right at 7, we get a 1 for our limit. And that makes the ratio test inconclusive. And we have to use a different test. So to earn the remaining 1 to 2 points, we are going to test what happens when x is equal to 1. And then what happens when x is equal to, I don't know why I said 1, 3. 3 and 7. 3 and 7. Okay, I go back to my series. You must write the sigma, you guys. You must write the sigma. Without the sigma, if you only write an n expression, you cannot say that an expression converges or diverges. Only a series or an integral will converge or diverge. So include the sigma. I'm going back to my a sub n term, and I'm replacing x with 3. So I'm going to have negative 1 to the n plus 1 times negative 2 to the n divided by n times 2 to the n. When I put in 7 for x, I'm going to have negative 1 to the n plus 1 times 2 to the n over n times 2 to the n. Well, over here, this is pretty easy. That just reduces to 1, right? That reduces to 1. So I am left with this alternating harmonic series. This converges by AST, alternating series test. So I know I get to include the 7 over here. Now we're going to see, do we include the 3? So over here, these don't reduce to 1. These right here, the 2 to the n's, they do not reduce to n. Okay, I'm sorry, they do not reduce to 1 or n. They do not reduce to 1 like this one did. This one over here reduced to 1. Okay? Because of the negative, I know it doesn't reduce to 1. I'm going to rewrite negative 2 to the n to negative 1 to the n times 2 to the n. I'm using a power of exponents that allows me to do that. That is, if we have two numbers multiplied together to a power, that is the same as a to the n, b to the n. So if I have negative 2 to the n power, which is negative 1 times 2 to the n power, I get negative 1 to the n times 2 to the n. That's why that works that way. Negative 1 to the n times 2 to the n. Divided by n times 2 to the n. Now these reduce to 1. Okay? The negative ones I'm going to combine by adding their powers. Since we're multiplying these together, I add the powers, and I get 2n plus 1 over n. I'm trying to figure out, is this alternating or not? Because if it's alternating, it's going to converge by AST. But if it's not alternating, it's going to diverge by P-series test. Okay? So is this still alternating? 2n is always even, plus 1 is always odd. This exponent is always odd for all whole number n's. So negative 1 to an odd is always going to be negative. That is negative 1 over n. Okay? This diverges by P-series test. Actually, I should take out the negative. Negative sum of 1 over n. Now it's a P-series, or you can say it's the harmonic series. But take that out, and then it's actually a P-series. Okay? Regardless, it diverges. So I can write my interval of convergence. It is 3 to 7. Keep the 7, don't keep the 3. That's my answer. Now, a word of caution, what I see students do. What I see students do is they do all of this beautiful work, which, by the way, I have seen this, they call this the analysis of the endpoints. The analysis of the endpoints. Sometimes that's worth a point alone, and then your final answer is worth a point alone. Okay? So there are your 5 points on this problem. Sometimes these two are combined to make 1 point. We just don't know what it will be, so you go and do it, okay? All right. Do not get lazy, you guys, and don't write this and instead go up and put a little line under here. If you do that, you're destroying your interior of the interval of convergence, and there's a chance that you would not get this point then. So don't do that, okay? Take the extra 2 seconds and write your answer down here, okay? Let's do another example. Let us determine the interval of convergence and radius of convergence for this series. Now, to get a good feel of what we're doing here, to get a good feel, okay, where's the center? The center is at 3. Right in the center is 3. no factorials. So I know that this does not converge for all real numbers. It always converges right at the center. I know it converges right at the center every time. And there's some interval around 3 where it converges. Okay? Outside of the interval, it's going to diverge. Inside of the interval, it will converge. Okay? All right. Now, I know I'm going to be doing the ratio test, right? I'm doing the ratio test. In the ratio test, this -1 is not going to influence my value of x. In the ratio test, this n squared is not going to change my values of x, because when the ratio test, this limit will go to 1, right? The 2, however, will affect my values of x. My answer to the limit is going to be x minus 3 over 2. I already know that. 2 is going to be my radius of convergence. Okay? I say this just to get a good feel for it. If this was x minus 3 to the 2n plus 1, or something like that. If this was 2 to the 3n plus 1, then you apply that power, okay? I would apply this power. That would be an 8, okay? Here this would be x minus 3 squared. So we would have to square root 8 to get the radius of convergence. Okay? All right. Let's work this out. Work this out. So I'm using the ratio test. Limit n goes to infinity. Absolute value. Okay? Ignore the -1. Replace every n with n plus 1. Replace every n with n plus 1. Okay. Multiply by the reciprocal of the a sub n term. Again, ignoring that -1. All right. You don't need to bother marking this up and scratching it out. Don't bother with it. When we take the limit, the n squared and the n plus 1 squared is going to go to 1. So I don't need to worry about that at all. I'm going to have the absolute value of x minus 3 on top. I have 1 left. Absolute value of x minus 3. I don't know why I put parentheses. I'm going to lose those parentheses in a second. Okay? And I'm going to have a 2 left on the bottom. We force this to be less than 1. I multiply both sides by 2. As soon as you get the x minus 3 by itself, this gives you the radius of convergence. So the radius of convergence is indeed 2. So the interval of convergence is 2 away from 3 in either direction. 5 on top, 1 on the bottom. 1 to 5. That is the interior of the interval of convergence. Now we need to go and check what happens when x is 1. What happens when x is 5? My series when x is 1 will be -1 to the n minus 1. I'm putting 1 in place of this x, so I have -2 to the n plus 1 divided by 2 to the n times n squared. When x is 5, my series is negative 1 to the n minus 1 times, I'm putting 5 in for x, so 2 to the n plus 1 over 2 to the n times n squared. Okay. All right. I don't care which we do first. I think I'm just going to do this first. I'm going to change negative 2. I'm going to change negative 2 to negative 1 to that power, whatever it is, times 2 to that power. Okay. Now, how do the 2's reduce? They reduce leaving a 2 on top. Right? They reduce leaving a 2 on top. What happens with the negative 1's? Add your powers. When we add our powers, I get 2n. So there's a 2 on top, and on the bottom, I just have the n squared. So my question is this alternating? Is it alternating or is it not alternating? Well, 2n is always even, and negative 1 to an even power is just 1. This is just 2 over n squared. The 2 can come out, and when the 2 comes out, I've got a converging p-series. So we converge at negative 1. I'm sorry, positive 1. Converge at 1. Over here, the 2's reduce, leaving a 2 on top again. But this time, I am alternating. And I'm not going to bother rewriting it. We don't have to rewrite it. All I need to do is say whether this converges or diverges and briefly state why. We must briefly state why it converges or diverges. This is still alternating. So it's alternating 2 over n squared. And that converges by AST, alternating series test. So both endpoints converge. The interval of convergence is interval of convergence is 1 to 5, including both the 1 and the 5. Okay, here's another way they can pose this question in an FRQ. They give us a series, and they tell us that it converges when the absolute value of x minus 5 is less than or equal to r. That is our radius of convergence right there. And that is what we are asked to find in this problem, r. So we're not going to have to test the endpoints because we're going to be done when we get to there. Okay? All right. Ratio test. Complicated with x's, ratio test. Every time. Limit, n goes to infinity. Absolute value, x minus 5 to the, I'm replacing n with n plus 1. Be careful doing that. We're going to get a 2n plus 2 over n plus 1 times n over x minus 5 to the 2n. Okay, as n goes to infinity, n over n plus 1 goes to 1. So this limit will be the x minus 5's reduce. We subtract the powers and we're left with 2 x minus 5's on top. Absolute value of x minus 5 squared. Okay? So like I said before, when you have a 2n, you're going to get this squared when you take your limit. All right? In the ratio test. We force this to be less than 1. Okay. Now since we have it squared, I don't necessarily need these absolute values. However, I want to keep them. And I find students make fewer errors if you keep the absolute values. I am going to square root both sides. Square rooting both sides. So I am left with the absolute value of x minus 5 is less than 1. So in class, students asked, Miss Murray, isn't that supposed to be a plus or minus 1? And I said, absolutely not. No, it's not supposed to be the absolute value of 1. Sidetrack, really quickly. Real quick sidetrack here. If you are solving this equation, if you are solving this equation, and you come in and square root both sides, the square root of 25 is not plus or minus 5. The square root of 25 is just 5. The square root of x squared is not just x, though. This is the absolute value of x, just like this is the absolute value of the square root of 25. Okay? The absolute value of that. If I were to graph in my calculator, if I were to graph y equals the square root of x squared, if I were to graph that, it would look like that. It is the absolute value of x. Try it. If you don't believe me, try it. That's the graph of that. It is not x. It is the absolute value of x. That is why we say x is equal to plus or minus 5. Not because the square root of 25 is plus or minus 5, but because the square root of x squared is the absolute value of x. Therefore, x can be positive or negative 5. Okay, sidetrack. So, no plus or minus 1. Absolute value over here. We just found our answer. Okay? So, r is equal to 1. Okay, that would be worth 3 points on an FRQ. In class, I let the kids do these next two on their own, in their groups. Okay? With the factorial on the bottom, this will converge for all values of x. For all real numbers, it will converge. On this one, the factorial, Big Mama, is up on top. There is not even a bottom. So this one will diverge for all values of x except the one where this series always converges. And that is the center value, 3. So it diverges everywhere except 3. So this multiple choice answer would be C. Okay, there's one other way that AP can ask us questions. I'm sure there's more than one, but this is one other way that they can ask questions. What if they tell us that? This is the series. I know what the center is. The center is 5. It converges at 8, but diverges at -1. Which of the following must be true? Well, if it converges, I know the center is 5. Let's think visually about this. Think of a number line. And I know at 5, we're at our center. So right in the center, put your 5, put your center. I know that we converge right there. I'm going to use green for converges. Green is go, so green converges. I know I converge right there because I always converge at the center. But they tell me that we're also converging at 8. So I'm going to count over to 8. 6, 7, 8. Over here at 8, they tell me that we converge. Well, I know therefore that there is this interval, a minimum interval where we must converge. So 3 units on the other side. I know I have to converge inside of here. The interior of the interval of convergence, I know I must converge. I know I have to converge inside here. What I do not know is what is happening right at this value. What is that value? 4, 3, 2. So that value is 2. I don't know what is happening right there. Let's do kind of a pinky purple for I don't know. I don't know what's happening right there. Maybe I converge, maybe I diverge, I don't know. Now, could the interval of convergence be wider? Yeah, it could be. But maybe not. All I know is that I'm converging at 8. Okay? And I know I diverge at -1. So diverge at -1. I'm just going to use my black for diverging. Okay, at -1. So 1, 0, -1. Here's -1, and I diverge there. I'm going to put an open circle for diverging. Okay, if I diverge here, then I know I must diverge after that. So I have to diverge there too. And because of the symmetry with our center, from here to here I converge an equidistant away, so 3 more units away. After that, I will also diverge. This is 9, 10, 11. Right at here, right at 11, I don't know. So there are 2 numbers where I don't know if I converge or diverge. I don't know there. And there are also, so right here, I'm going to highlight it yellow. Maybe that'll stand out. Yeah, it stands out good. Okay, I don't know. And I don't know here, and I don't know here. But I do know I must converge here, and I must diverge there. So which of the following must be true? Diverge is at 9? Nope, that's in my I don't know spot. Converge is at 2. I don't know what happens at 2. Diverge is at 0. I don't know what's happening at 0. Converge is at 3. Yes, that is true. That must be true. So D would be my answer there. Okay, let's do another one. All right, what's my center? My center, I'm going to do my number line way down here. My center is -2. So I converge there. I definitely converge there. Green. I definitely converge there. Okay. I also converge at 2. So -1, 0, 1, 2. I know I converge at 2 also. Because of that, on the other side of my center, 4 units away, -1, I'm sorry, -3, -4, -5, -6. Okay. I don't know what's happening right here. I don't know. But I know up until then, I converge. I converge, 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 all there. Okay? I diverge at -8. -8. I'm diverging right there. Okay, had a little slight interruption there. Okay, so I know I diverge at -8, which means that maybe I should put an X for divergent. I diverge at -8, and that means that after -8, or on this side of -8, I must diverge. I must diverge there. That leaves us with a bit of an interval of unknown. So this is unknown. I don't know. Okay? But on the other side of 2, 2 units away, up until 4, after 4, I must diverge. But right at 4, I don't know. I don't have that information. So here's another unknown interval here. So you'll have some intervals, some pieces where you don't know, but you have intervals where you do know. And we are asked here which of the following must be true? Must be true. So, converges at -6, I don't know. Converges at 3, I don't know. Diverges at 6, yes, that must be true. So I found my answer is C. Diverges at 4, I don't know about 4. Alrighty. One last way that they can ask us. This series converges conditionally. I remember the year, a couple of years ago, a few years ago, I thought I was teaching this great. I thought I was doing such a good job. And then on the practice exam that year, there was this question, or a question like this, about converges conditionally. You guys, the only way that we can have a value that converges conditionally is if that value is an endpoint of the interval of convergence. So x equals -1 must be an endpoint of the interval of convergence. It's the only way it could happen. Okay? So when I draw my number line here, my center is at 4. My end point is at -1. Okay? So my other end point must be at 9. Now, I don't know if I converge or diverge there. This is a question mark. But I know I converge here, and I know I diverge everywhere else. So the only number on this whole number line that I do not know is 9. And this says, which of the following must be false? Must be false. So, the series diverges at 9. I have no idea. The series converges at 9. I don't know. The series converges at 7. Well, the series does converge at 7. That's true. I don't want it. I want false. The series diverges at 7. That is the false one. So D is the answer here. Okay. That is intervals of convergence. So a big, big topic for us, really important. So thank you for watching.